Today we're going to cover how to use strain in LabView and then calculate Young's modulus using formula blocks, and then saving all our information into one right to measurements file with labels for each section so that we know what we saved. Okay, so first we're going to hook up our DAC. So you hook up your DAC to the USB port, and then you're going to go ahead and open LabView. Start a blank VI using Control-N or another method, doesn't matter. We're going to insert a DAC first, so go to Express Input DAQ. This time we're going to hit Acquire Signal, Analog Input, and Strain, since we're reading strain directly, and it should show up the DAC there. You're going to use the AI0 port. So once you have selected the strain channel that you want, AI0, you'll get this window showing the setup for it. You leave the input range the same, then you will change the gauge factor to 2.05. The gauge resistance we're using for this lab is 120. The V excitation source is external. The excitation value of the external source is 5. And the strain gauge that type we're choosing is half bridge 2. You leave the lead resistance as 0 and the scaling as no scaling. Then go to the Device tab, click Strain Calibration, uncheck Enable Shunt Calibration, then click Next, and then it will measure the strain on the computer to make the initial strain measurement. Now you hit Calibrate a couple times until the system kind of levels out. Once it has, and you see the successful calibration, hit Finish. Then go back to the Settings tab, and you'll notice there's an initial voltage here. You'll want to write this down so that you have it for future references, that this is your initial voltage, and the M here stands for milli, so this is 12 millivolts as the initial. Once you have all these settings done, and you calibrated the strain, and you have an initial voltage here, and these settings are all correct, then hit OK. Now we're going to create controls for the sampling rate, and then a control for the number of samples. And then we can create our graph to show what the strain looks like over that range. So I'm going to go ahead and call that strain. All right. So now this is strain coming out of it. Now you're collecting multiple samples over a period of time. So in order to get a single value for strain, you're going to want to average that value of strain. So we're going to go ahead and insert a mean from mathematics, probability and statistics, and mean. You go ahead and connect it to the output of the DAC, and then create an indicator for it. And I'm going to call this mean strain. And this is going to be a very small number, so you're going to want to expand this and make sure that you go in the properties of this indicator by right-clicking, go into properties. Then display format, you're going to want to show probably about 8 decimal places, so change it from 2 to 8. And I'm going to move that right below my graph of strain just to see what it, so I have a mean of it. So now we can see the strain, we can see the mean strain. Now that we have the mean strain, we like to calculate Young's modulus directly in LabView. And you're going to do that by first inserting a formula block, going to Express, Arithmetic and Comparison, Formula. Now the formula for Young's modulus is equation 6 in the handout, which is 6 times the weight times the length between the strain gauge and the weight's location, divided by the strain times the base of the beam times the height of the beam squared. So what we're going to do is we're going to insert variables for weight, LS, strain, base, and height. Now when you do the measurements of the base, height, and LS, do it all in metric units. So we're going to have mass because we're going to convert that to weight. You have LS, you have E, you have base, and you have height. So the equation is 6 times the mass, but mass is only in kilograms, so we need to convert that to newtons to be a weight. So we're going to times by gravity, 9.81, times LS, and then you're going to put all this in parentheses because you're going to divide now by strain times your base times your height squared. You can do this two ways. You can do height times height, or you can come over here and do this double star and put 2 for squared. So now we've successfully inserted the formula. Now we're going to take our mean strain, connect it to the E for strain in the formula. Our resultant is going to be, we're going to create an indicator, and that's going to be Young's modulus. Now mass, we got to input that, so we're going to create a control for it. So before you hit run, you input the mass, you input the distance from the strain gauge to the mass, and then you put in the height and the base. And you can put all of these on the front panel as controls, so you don't have to switch back and forth for the calculations of Young's modulus. So now, when we go to our front panel, we'll have our strain graph, we'll have our mean strain, we'll have our number of samples, we'll have a rate, and then here we have our controls for the values going into Young's modulus. So I'm going to go ahead and organize those in a little fashion so I know where to change them. And again, I would insert these in metric unit. Kilograms and meters is what you're going to want to insert them in as, because that equation that you're inserting, it should be in the base unit. So mass is kilograms, and then length is in meters. So make sure that you insert these in meters, kilograms, etc. So to remind me of that, I'm going to go ahead and next to mass, I'm going to put kilogram. Next to LS, I'm going to put meter. Next to B, I'm going to put meter again. Next to H, I'm going to put meter as well. And then next to my Young's modulus, the units I'm going to put is gigapascal. Now strain doesn't have any units, so you leave that alone. And if you want to be fancy and put units in for your rate, it's in hertz. So now I am calculating my Young's modulus in LabView directly based on my mass, my length from my strain gauge, and my height and my base. Now you can make the height and base a constant here in the block diagram, since that doesn't change. So you would only have to change the mass and the length scale every time you do it. So you insert your base, you insert your height, and then when you're doing, before you hit run, you put in your length, and before you hit run, you put in your mass, then you hit run, and then you keep your length constant to your next weight, put the next mass in, hit run, and go on, and etc. until you have 3 for that LS, then you change the LS and have another 3, and then you change your LS and have another 3, so you get a total of 9 measurements. Now, I want to save all of this data into a write to measurements file. So I'm going to right click, and I'm going to insert my write to measurements file, and I'm going to go to output in ExpressVI. And I'm going to leave the time column as one column only. I'm going to keep my headers as such, my text LVM, and I'm going to use the next available file name for mine, and I'm just going to leave it in the default location for this time. And then I'm going to right click, I'm going to go to Express Signal Manipulation, insert my merge signal. So I'm going to connect the merge signal to my write to measurements file. The first thing I want to save is I want to save my raw strain data. That way I could take the mean myself later on and see what's going on. Then I want to save my mean strain. Then I'm going to save my mass. Then I'm going to save my LS. I'm going to save my base and my height. finally, I'm going to say my Young's modulus. So if I go back and I hit run, you get whatever you get, and it'll save the file in the location you specified. I kept the default location, so it's under Documents, and it's under LabView Data, and I'm going to open that in Excel. And since I used next available file name, there was already test 1 through 8. It showed up as test_9. And then you can see here, I have my strain, my x values of time, my strain value, my average strain. Then I have my mass, my LS, my base, my height, and my Young's modulus. Now it says NaN for Young's modulus because I didn't put any values in for the mass and etc. Now if you want to be really fancy, you can use what you learned in Lab 3 to calculate, or not calculate, to label all of your signals going in. So instead of having to delete all these wires going in, I'm going to go ahead and insert my attributes after my merge. So I'm going to go signal manipulation, attributes, and I'm going to say signal name. And I'm going to create a constant for both. And the first one I'm going to say mean strain. And that's going to be number 1, because that's the second wire I have going to my merge. Then I'm going to take the same exact block and copy the controls and everything. And I'm going to say signal 2, which is, when you look at it, you follow your wire, which is my mass, in grams, or kilograms. So I'm going to type mass, kilograms, so I know the units. And again, I'm going to take the out of the first attribute 1 and put it to the end of the second one. And I'm going to delete this one going from out from the merge, and that's going to come into my attributes. I'm going to move these up. Excuse me. And now I'm going to paste another set attributes. This time it's going to be 3. And this one is, take your third one, or should I say your fourth signal, and follow it. It's LS. And LS is in meters, so LS meters. Connect the signal out to the signal in. Put another attributes in. And this one's going to be 4. And this is my base. So I'm going to say base meters. And I'm going to insert 2 more attributes, 1 for height and 1 for Young's modulus. So I'm going to go ahead and connect all these up, and then after that, I connect it to my right to measurements file. And I connect this out to this attribute 1, and I can move the wire down here. I change this to height, meters, and this one I change to Young's modulus, gigapascals, and this is 5 and 6. So now I have everything that I need to save all the results, and then name the results and attributes. And then I am automatically calculating Young's modulus inside LabView. So then when I go home, I don't have to calculate it. Now I'm going to create the normal controls for my right to measurements file. I'm going to create an enable button, and then the file name. And then I'm also going to create an indicator to determine if I'm actually saving. And then I'll create my file out indicator so I know what file I just written. So now this is my completed LabView for this lab for lab 4. And if I go to my front panel, I'll have all my saving data right here. And I can move that. And then I can take my enable. And I can make my button bigger so it's easier to press. So here I have my controls for my file. Here's the controls for the DAC itself. Here's the controls for the beam's properties and also the mean and the mass and the length. And then down here we have our mean strain with our Young's modulus. Now when I hit run, it's going to save it in the default location as the next available file name, which is test 10. I'm going to go ahead and open that. And then when you look, you can see that we have everything labeled with the units we used, with each column labeled properly. So now we have an idea of what the values are. And you have the raw data in addition to the average and the calculated data. So if something goes wrong, you have the raw data to fall back on. So I'm going to go ahead and close out of that. So this is how you set up LabView for the strain gauge lab.